Today we are going to present the another important topic on geomorphology, that is the plate tectonic theory, which is one of the most important theory that helps us to understand the whatever the geomorphic features are represented in our Earth's surface. The plate tectonic theory can explain how the mechanism of the formation of these landforms, and it also give evidences of continental drift and seafloor spreading and the major landform that are represented in our Earth's surface. So why we are going to study this theory? Because the Earth's geography has changed over times and continues to change today. So there are several places where the earthquakes are found, and some places where earthquakes are not happening. So what are the reasons behind this? So that can be explained through plate tectonic theory. In some of the regions, like volcanic eruption is occurring in some of the regions, and in some parts this volcanic eruption cannot be found. So this is also the one of the basic aspect to understand about this plate tectonic theory. Mountain ranges, ore deposits, living and fossil fuels of the plants and animals, all are the features that are found in our Earth's surface. This plate tectonic theory helps to explain, to understand how the formation of these features on our Earth's surface. So actually plate tectonic, it refers to the deformation of plate or interaction of plate along their margin. Plate tectonic refers to deformation of plate or interaction of plate along their margin. This plate first informed by Wilson in 1960. He is a Canadian geophysicist. After that, in 1967, Mackenzie and Parker presented a paving stone hypothesis. To represent the oceanic crust in the mid-centuries, and he also described this plate tectonic theory. And this theory is represented through Euler's geometrical theorem, according to this theory, if we consider the Earth as a sphere, the plates of the lithosphere can be moved to another position on the surface by rotation along its axis. So if we consider Earth as a sphere, the plates of lithosphere can be moved to another position on its surface by rotation on its axis. So there are some basic premises of this theory. First, plates are rigid lithospheric slab that floating over denser asthenosphere. plates are rigid lithospheric slab. Floating over denser asthenosphere. These lithospheric slabs are broken into various places. These are broken into various places. The larger slabs, major plates, smaller slab, minor plates. Four. The amount of material is fixed as the amount of new plate is created and the same amount of new plate get destroyed. Amount of material is fixed. And the divergent plate are characterized by high emerging flow, convergent plate or low emerging flow. High emerging of flow and convergent plate low emerging of flow. So these are the basic premises to understand about this plate tectonic theory. This plate tectonic theory can be described in two ways. One is the geometric part and another is the kinetic part. One is geometric part and second is the kinetic part. So this geometric part, it describes about the number of plates, shape, size, and then nature. Kinetic part, it deals with the motion and resultant reaction, mechanism of plate. And mechanism of plate. So based on the nature, we can say there are three types of plates. One is purely oceanic, purely continental, and partly oceanic and partly continental. Or partly continental. So purely oceanic, like Pacific plate. Purely continental, like Eurasian plate. And partly oceanic, like Indo-Australian plate. So in lithosphere, this is broken up into the 7 major plates and 6 or 7 the medium size regional plate and several small. However, these plates both are in amorphous condition. These are amorphous condition. So how these plates are reacting? All these plates, there are some margins, and when the plates are moving towards each other, they are meeting with another plates within a plate boundary. So plate boundaries are the edges where the two plates are meets. Plate boundary the edges where two plates are meet. Right? And the most of the geological activities like volcanoes, earthquake, mountain building, etc. occurs in this plate boundary. So there are 3 types of plate boundary. One is the divergent, convergent, and transform. These are the 3 types of plate boundaries are found. Divergent, when the plates moves in opposite direction. Suppose this is one plate, this is another plate. When the plates are moved in opposite direction, then it is called divergent. Convergent, when the plates move toward each other, then it is known as convergent. Suppose there is some plates, these are the plates that is slip past each other, then it is known as the transform plate boundary. So what are the difference between the plate margin and plate boundary? That is, plate margin is the marginal part of the plate. These are the marginal part of the plate, and plate boundary where the plates are meets. So a single plate having a plate margin, but there is no boundary. Right? Now the question is that what are the forces that are influencing this plate movement? There are several hypotheses, several theory has been developed by different geomorphologists and scientists and geophysicists. But there are several there are 3 important forces that have been proposed, the main drivers of the plate. One is the mantle convection current, here the warm mantle currents carry the plates of lithosphere along a conveyor belt. According to this factor, that mantle convection currents. It's carry the plate. It's called mantle drag. Second one is the ridge push. Or buoyant upwelling mantle at mid-oceanic ridge. Here newly formed places at oceanic ridge are warm and so have a higher elevation at the oceanic ridge than colder, and the higher plates at the ridge to push away the lithosphere that lies further from the ridge, like it push away the lithosphere. Therefore, the mid-oceanic ridge is formed. It's called ridge push. Third one is the slag pull. Here the older and colder plates sinks down at the subduction zone. This is the zone is known as the where the denser plate is subduct under the lighter plate, and the cooler and this is causes the movement of the plate. So there are several evidences of the plate tectonic theory. First one is the age of the plate, like continental plate is the age having 3.5 billion years, where the oceanic plate only 75 million years. So it can prove that the older rocks are continental while the younger rocks are oceanic, and this proves that the plates are moving, and therefore this continent has developed earlier rather than the oceanic plates, because most of the movement of the plates is occurred in the ocean boundary. Second, temperature gradient. Normal temperature gradient on the ocean floor is 9.4 degrees centigrade per 300 meter, but near the ridges it's become higher, and the plate boundary regions are mostly affected by the earthquake and volcanic disturbances. That proved that the theory of plate tectonic, that plates are moving to different direction. It may be convergent, especially the divergent boundary, where most of the activity like volcanic eruption, earthquakes are occurs due to the molten metal rises due to the movement of the plates in opposite direction. So these are the basic evidences of the plate tectonic theory, and thank you for watching this video.